I am Narsimlu Madhuri. In this lecture, I am going to discuss how to implement a comparative approach to predictive analytics with machine learning for fraud detection of real-time financial data. The agenda of this lecture is what is an existing system, a proposed solution, the approach which I followed to implement this project, the process flow diagrams, the architecture of this project, technical aspects, the technical concepts and technologies which I have used in this project for implementing, few code snippets, sample screens, conclusion and feature enhancement. Let me discuss one by one. In an existing system, a comparative approach to predictive analytics with machine learning for fraud detection of real-time financial data. Let me go in detail about this project. Digital strategies coping up with banks, financial institutions, enormous data passed to this sector. Business transactions are becoming more prone to frauds and threats resulting in data leakage, sometimes fraud transactions, personal details exposed to fraudsters leading to huge loss to organizations as well as customers. This makes organizations adapt to high level security and data handling solutions like machine learning, deep learning and predictive analytics. These are efficient enough to deal with highly sensitive data. This is existing system. Let me go with the proposed system. In the proposed system, I propose predictive analytics with decision tree for fraud detection of real-time financial data. After building the model, I am deploying that model on the Flask web framework. In a mathematical techniques or hypothetical models is developed in support of traditional approaches added with predictive algorithms to give strong analytical solution. This is I propose to implement this project. Uh, Introduction to this project. The key to business decisions in real time. One of the driving factor which is greatly responsible for transforming the banking industry is the artificial technology. The key features of artificial intelligence technology that leads to advancements and smarter results such as anomaly detection, contribution analytics. What is anomaly detection? Anomaly detection technique to detect unusual or undefined patterns in the data that do not direct towards the expected outcome. This technique has been widely used in predictive analytics for analyzing the data, critical or raw points in the data and identifying features to extract the best results. That is about anomaly detection. When it comes to contribution analytics, provides the users with the reason and context in which the event has occurred and further within its results. This is contribution analytics. Real-time predictive analytics. What is a real-time predictive analytics? which is preferred on an aggregated predictive model, is deployed for a raw runtime deployed for runtime prediction continuous streaming data, leading to a real-time powerful decisions. This is real-time predictive analytics. What is real-time financial data? Real-time data is information that is delivered immediately after it's collected. Real-time data is a strategic priority. Data and analytics are the key accelerant of an organization's digitization and transformation efforts. Benefits of real-time financial data here: understanding business performance, detect fraud and error faster, improve the accuracy of business predictions, forecasts, and goals. Another one, make strategic business decisions. This is about the key business to decisions in real time. Let me talk about the data here. What data I collected for implementing this project, which is suitable for implementing this project. I did a lot of research to get these data. Here I downloaded the data from Kaggle here, and I took the data from the Kaggle, which is a financial data sets for fraud detection. About the data here, about the data step, these are the attributes which are there in the data set: step, type, amount. Step is the time, the amount of time maybe transaction happen, type, what type of fraud may happen, the amount which the transaction fraud happen, and then name of the organization, old balance and the new balance, is fraud or not. So these are the attributes which are there in my data set. Now, the approach which I followed to implement this project: first I identified the data, so the data source, and I did study and financial data predictive analytics algorithm. First of all, we should know what is mean by predictive analytics algorithm. Then I'll go for the predictive analytics with machine learning algorithm. Fraud detection of financial data using a decision tree. I use a decision tree for implementing this project. I deployed this model on the Flask web framework. Let me see. The fraud detection of financial data sets. For fraud detection, the data set is here. So you can, once you click on this, you can, I'm clicking on this, bear with me here. I'm clicking on this. Once I clicking on this, automatically it is navigating to that page here. Financial data set for fraud detection. This is the data. This data, which contains 11 columns, around 63 lakh 62,000 observations. The observations are there, means records are there. This is the data here, the column, these are the columns, 11 columns are there. This is about my data set. So once you download this, here from here we can download the data set. After downloading the data set, we can add it to the drive for doing our project. This is about my data here. So it contains 63,62,620 observations, means here instances, those are the records, and 11 columns are there. This is data description. So step is in integer form, which is the time here, the duration, the transaction has happened, the type, what type of transaction, the amount, name of the organization, old balance and the new balance, and name, destination, and old balance destination, new balance destination, is that fraud happen or not. This is a boolean value. Here 5 are float and 3 are integer attributes are there, 3 are object attributes are there. Now what is predictive analytics? The predictive analytics is the use of known data, statistics and machine learning to predict future events. Many companies here in the predictive analytics, many companies are using predictive analytics to forecast the future and make automated and manual decisions that drive business value. Predictive analytics does this by taking customer data, transforming it into knowledge about the customer. Predictive analytics fundamental components are: data is a fundamental component, statistics modeling is a fundamental component. These are the three components, fundamental components. See in this diagram here, predicting here, you are predicting, classifying from the past data, predicted here. First of all, what is data? The most common barrier faced by organizations trying to implement predictive analytics is a lack of reliable data. When it comes to the statistics modeling, regression analysis, which estimates the relationship among different variables, is the primary tool used by organizations for predictive analytics. That is all about statistics modeling. Every predictive model has an assumption behind it. It is important to know what that assumption is and monitor whether it is still true. This is only the assumption. Predictive model typically include in a machine learning algorithm. That is included in the machine learning algorithm. The predictive analytics which is included in the machine learning algorithm. Now when it comes to the predictive analytics modeling, what is predictive analytics modeling? Let me see. Predictive analytics modeling is which is included in the machine learning algorithm itself. In this, we are predicting the future data, that predictive models which are included in the machine learning itself. The most widely used models are decision tree, regression, neural network. What is decision tree? We should know what is decision tree. Decision tree is a type of supervised machine learning used to categorize or make predictions based on now a previous set of questions were answered. This is only the decisions. Coming to regression analysis is a statistical method that helps us to analyze and understand the relationship between two or more variables of interest, which is regression. Coming to neural network. A neural network is a series of algorithms that endeavors to recognize underlying relationship in a set of data through a process that mimics the way the human brain operates. In this diagram here, predictive modeling define objective. Objective is the what is the objective of our problem. First of all, that we have to identify the objective. Then we have to indicate is it comes under regression or classification, that has to be identified. Then after that we need to collect the data, get the data from the source, from where we have to get the data. Once we get the data is collected, that is raw data. Once we got a raw data, we need to process the data. Once we process the data is ready, meaning here if there is any unnecessary data is there, unnecessary columns are there, that we need to process it. After that we have to explore it. Exploration is understanding the data, how the data looks. Then decide on model. Which model is suitable for your objective, for your project, that we need to decide. Once we select the model, then we have to train it. So we have to split the data into two parts here, feature set and target one. Then we have to divide into train set and test set. Then after that we need to build the model. Once we build the model, that we can deploy on any front end tool for see the results interactively. So we can go for that. This is about predictive analytics modeling. In this I selected decision tree for implementing this project. Predictive analytics process is like this. First of all, we need to define the project, then collect the data collection, then data analysis. We should analyze the data, see the statistics about the data. Then we need to model the data, meaning here we need to build the model. Once we build the model, that model we can deploy on any front end framework. Here I use the Flask framework. Then coming to the data here, so I collected the data from Kaggle. I collected the data, then once we collect the data, that is financial data set for fraud detection. So that the data is not in a required form, that data we need to bring it into a required form. So for that we need to apply data pre-processing techniques to clean our data. Then we need to select the model selection and training. We need to train it. Then for building the model, I use the decision tree. This is a decision tree, which is a predictive analytics algorithm. I build the model. Once I build the model, so I need to save it. Once I saved it, then only I can deploy it on the Flask web framework. So after building the model, we need to check how much accuracy we are getting for future prediction or future events. So that is model evaluation. Here I use the accuracy score for evaluating the model. This is about data. And now when it comes to data visualization, exploring the data. So suppose to find out the missing values in the data set, you can apply this exploring missing data. Describe each column data. So is the data is in a categorical form or continuous form, that we need to check it. Then explore categorical or continuous variable for each column. Then we need to correlate the dependent and independent variable, that is target variable and feature set. So which variable is predicting the outcome? That is primary attributes we need to identify, secondary attribute we need to identify. The attribute which are not influencing the output variable, that we can ignore it, or else we can remove it from our data set. This is about data visualization. When it comes to data pre-processing, this is very important phase in a data science projects. Most of the data science application, this is a major, the very important phase. It plays major key role in data science applications. Data pre-processing is a process of preparing the raw data and making it suitable for a machine learning or deep learning model. It is the first and crucial step while creating any machine learning model or deep learning model. It is not always a case that we come across the clean and formatted data. What happens, sometimes the data may be in a right form, we need not to apply any data pre-processing techniques. It is not at all required. If the data is in a desired form, the required form, need not to apply data pre-processing techniques. Whenever it is required, we need to convert our raw data into a clean data set. Basically what we'll do here, first we'll identify the handling the missing value. If there is any missing data is there, if it is a categorical data, that data we can replace with the mode. If we have more number of observations in that respective column, we can ignore it. If not, if you don't want to lose any data, so we can replace with the mode. In case of continuous, we need to if it is a continuous, we need to replace with the mean. Now encoding is we have binary encoding and label encoding and one not encoding. Binary encoding, we have only two classes, either true or false. Label encoding, you may have two or more labels. One not encoding, we have one column may have the different classes, that also we can label it, we can encode it. Now future scaling, so scale the data according to our requirement. We need to bring the data into standardization form. Sometimes the data may be in integer form, or float form. To bring the data into uniformity, then we can standardize the data. And normalization, which is used to remove the duplication from our data set. So this is all about data pre-processing. This is the architecture of predictive analytics. First, what we'll do here, first original data set. In the original data set, the data set which we have collected from the source. Once we collected the data, so once we collect the data, we have to do a lot of things here. First, we need to process the data, that is data cleaning. Here we need to clean it. Then these are all optional. So if there is any dimensionality reduction is required, we need to reduce that dimensions also. Augmentation, this is oversampling, this is also optional, not mandatory in all the cases. Ready to use training data set, once the data is ready, that we can use it right here. So we are training the data set, because you are training the data set according to our problem statement. What columns are required, what columns are not required, what attributes or missing values are there, that we need to check. Ready to use training data set, if the training data set is ready, then we can split into training data and test data. Training, so that training data we can give it to the classifier, that is machine learning classifier. Then here validation is there in the machine learning, because the predictive analytic model which includes in the machine learning itself. Here it is including in the machine learning itself. Here this is connected with the machine learning. The post processing, this is moving the threshold values, and then we need to evaluate the model with the metrics. Metrics are used to validate the model which we build. So to validate that model, we will apply metrics, classification metrics and regression metrics. We have in classification metrics, we have confusion matrix, accuracy score, classification report, AUC, area under curve, ROC curve. Whereas in regression, we have RMSE, root mean squared error. This is architecture of my project. Now, after building the model, what I am doing in the project, because it is not there in the uh, existing system, I propose this. After creating my model here, this is model creation. Once we created the model, once we build the model here, that model I am deploying on the Flask framework to see the runtime, that is real time data. So the real time data we can give it to the data, we can give it to the model, so then it gives the predictions. That predictions we can see it on front end, so which is the financial data I am taking here. This is my financial data. After building that model, this is a machine learning model. The machining once we build the model, that model has to be saved in any drive or else in a personal PC. Once we save the model, that model we have to load it into the browser here. So I'm using to save the model pickle module I used to save the model. So once we save the model, that model we have to load it onto the browser. So this is my Flask framework. So here I am loading it, pickled model. So because saved model, for splitting the data, I use a sklearn library. Sklearn library for splitting and evaluating the performance of model. I use a sklearn only. This is the architecture of my project. Let me see decision tree algorithm. This is very important for implementing this project. First of all, we should know what is decision tree. Decision tree is a tree-like structure that is used as a model for classifying data. It can be used as the decision tree can be used for classification as well as regression also. But in this project, I am applying classification technique for classifying my data. It is a supervised machine learning technique where the data is continuously split according to a certain parameter. So decision tree analysis can help solve both classification and as well as regression problems. The decision tree algorithms break down a dataset into smaller subsets. A decision tree decomposes the data into subtrees made up of other subtrees or leaf nodes. It is decomposing. The root node is decomposing into two parts, the left side and the right side. Those are leaf nodes, decision node also. But decision tree is made up of three types of nodes. First node is your decision node. This type of node have two or more branches, means left side branch and right side branch. The leaf node, the lowest node which represents decision, because we are classifying our data either binary classification or multi-class classification. Here I used only binary classification, which just whether fraud has happened or not. So true or false only, 0 or 1. The leaf node, yes or no. In the root node, this is a also a decision node, but at the topmost level. Let's see the diagram, you can easily understood. So here decision node is a root node. This is my root node. Is a topmost node in the tree structure. This is subtree. Decision node, which again it is decomposing into left node and the leaf node and the two leaf nodes. This is the left side and the right side. This is another decision node. If there is no more splitting is possible, then we have to keep on split the decision node into several parts till there is no more split is possible, because it depends upon the information gain that we'll see. This is all about the decision tree algorithm. It works like this. This is pseudo code of decision tree here. So we have to take the data set here, that is learning set here, that is a data set. We have to use the data set, then attribute set, attribute values, loading a learning sets and create decision root node. The root node is a topmost node. Add learning set yes into root not as its subset. It is not a subset, it is only the main node for the tree. For root node, we have to compute entropy. Because these two, entropy is a metric which is used to construct the tree. This entropy and information gain. I'll talk about this in the next slide. I'll talk about this. Entropy of a root node we need to calculate first. Once we calculate the entropy value, then based on the entropy value, whether the tree is going to be splitting or not, based on that value only. If entropy is equal to 0, means here the subset is homogeneous, all the values are similar only in the subset, because we have to return the leaf node. If entropy is not equal to 0, subset is not homogeneous, means those values are not similar, then the splitting. Compute information gain for each attribute, that is left side and the right side, not being used for splitting. So for find attribute A with maximum information. If the information gain is maximum, there is a possibility of splitting the tree. Create a child node for the root node. Add to root node in decision tree. For each child of the root node, we need to compute information gain. So again, because the decision tree which works on based on the ID3 algorithm, apply ID3. So same learning set, attribute set and attribute values continue until a node with entropy value is 0. If their entropy is 0, then there is no more splitting is possible. That is a last node in the tree, that is leaf node is reached. See the example, then you can easily understand. These are metrics I need to explain, because these metrics are very important here. Entropy and the information gain. There are metrics used to train decision tree. First one is the entropy and the information. What is entropy? Entropy is an information theory metric that measures the impurity or uncertainty in a group of observation. It determines how decision tree chooses to split data. And consider a data set with n classes. The entropy may be calculated using this following formula. E is equal to minus of I is equal to 1 to n. N means here number of classes. Then with data set with n number of classes, P of I, probability of I. This is where P of I is the probability of randomly selecting an example in class I. Then another metric is in decision tree is information gain. Information gain as a measure of how much information a feature provides about a class, because the information gain is more important in constructing the decision tree. Information gain helps to determine the order of attributes in the nodes of a decision tree. Information gain to determine how good the splitting of nodes in a dish, how good to split our tree, our decision tree. The information gain will be calculated using this formula here. Gain is equal to entropy of parent node and minus entropy of child node. Entropy of child node means we have to calculate the left child and the right child, that we have to take average. Here E parent is the entropy of the parent node, E children is the average entropy of the child node. There is a left and right, because the node has, the decision node has. I am taking the simple example for the sake of easy understanding. Then same thing we can apply to my project also. It represents factors that affect whether the Ram would go out to play golf or not. Here this is my dependent variable. These are the feature attributes: outlook, temperature, humidity and windy. Based on this parameter, whether this person Ram would go out to play golf or not. So here we have two classes, either yes or no. First, what we have to do, first of all we have to identify the root node. For that we need to determine the classes which are the basis for constructing the decision tree. In this Example, play golf is a root. There are two classes, which is yes or no classes. To determine root node, we need to compute the entropy here. Yes, number of observations in that category is 9, no 5. So we need to calculate the entropy of this and play golf. E of 5 comma, because we need to calculate the entropy using the sigma I is equal to 1 to n. Here we need to go, there are two classes are there here. I 9 means here first one number of, because two classes are there, 9 by total number of observations are 14, log 2 9 by 14. This is the formula I applied here. Here this is what p of I log 2 into p of I, that we need to apply here. So minus, first minus of minus 5 by the second class, 5 by 14 log 2 into, so we'll get this value here. This we can calculate it with only the mathematics here. Then we need to compute entropy for other attributes for splitting. We need to calculate the entropy after each of the split. So this is a frequency table of my outlook here. This is outlook. In the outlook here, sunny, because I need to take the root node. Root node is play golf is a root node here. So this is another attribute, possibility attribute for splitting my decision tree here. Sunny here. We have 3 values for S and 2 are no. Total number of value observations here 5 here. Whereas in overcast we have 4, in rainy we have 5. So like this we need to take the combination here, combination of all the categories, entropy of play golf comma outlook, entropy of play golf comma temperature, and the humidity and the windy. So we need to calculate like this. So just simple thing is here, move for more than one attribute. In the we have seen only for entropy of single attribute, more than one we need to calculate this. So P of C into E of C, so that we need to calculate the P of sunny and probability of this and entropy of this, plus probability of overcast plus, into entropy of overcast, probability of rainy into entropy of rain. So just this we need to calculate the play golf outlook entropy value. So this is a frequency table. For each one we need to calculate the entropy here, entropy of this, I am getting this. So entropy of overcast is 0, entropy of rainy is this. So the total entropy for play golf and outlook is 0.69. So same thing like we need to calculate for the temperature and the humidity also. So I calculated. So finally same thing we need to repeat here, play golf outlook, temperature, humidity, windy. So these are the entropy values. Based on this we need to split it. So for that we need to calculate the information gain. The information gain is calculated from the split using each of the attributes. Then the attribute with the largest information gain is used for split. This is gain of S of t. This is entropy of root node minus entropy of child, that is left and right we need to take. Entropy gain of play golf outlook, so we need to calculate the this is my root node, this is a child, same thing like remaining. So first outlook, temperature, humidity, windy. This is after calculating entropy and information gain. If the information gain is more, then possibility for splitting that. First, the highest information gain comes from outlook. Therefore, see the information gain which we got from the outlook is 0.2. For temperature I got 0.02. For humidity I got 0.1. The highest entropy, the highest information gain we have to consider. Then information gain is more because we gain more information in that decision node. Here this is the decision node. it is taking the decision for splitting our tree. Same thing, like we need to calculate for this, we need to calculate for this. We have to repeat till there is no more. For further splits, the sunny and rainy attributes need to be split here. Here we have to take here a rainy and humidity. So here high and normal. I got it. This is complete decision tree. It's keep on iterating. Same thing like here sunny and windy, true and false, no or yes. This is our final prediction is required like this, no or yes, no or yes. This is the way to construct the decision tree. So in the decision tree there are two major metrics we have to understand. What is the entropy and the information. Based on entropy and the information gain, the tree is going to be constructed. Coming to the technical aspects here, so I use ID here, Google Collaboratory. I used it here for doing this project. So I collect the data which is the financial data. I used I used in this project. And next, decision tree here, the algorithm which I used, decision tree, the language which I used, Python. So decision tree for fraud detection of financial data. So you have to go to the collaboratory and load the data and visualize the data to understand what type of data is available in the data set. So we need to do all those steps. Let me show you the implementation part. This is implementation part. I did it. These are the required libraries: pandas, numpy, matplotlib. These are the libraries which are required for my project. For pandas is for loading the data, for data preprocessing also we can use it. Numpy is for creating the numerical Python. So this is a way to load the data which I have in my drive here. I just loaded it. So I renamed the columns because easy way to understand my columns. I renamed it. And I want to know what type of data is it, numerical or categorical. If there is any encoding is required, just I have seen the type of each column. To know the missing values in the data set, just I used it. Exploration, I explored the data here, the exploration of data analysis. This I did it. This is all I did it. For data cleaning also I did it here. So because some of the attributes are having categorical values, that I encoded it with 0 or 1. So identify the target and feature set. The target set is a fraud here. Target label is fraud. Is a fraud that I need to predict it, detect it. Then I applied the visualization also. So stripped homogeneous fingerprints of genuine and fraudulent transaction over the time. The time is that step here. So genuine and the fraudulent transaction, if there is any fraudulent transactions happen, this is same and genuine fraudulent transaction over the amount, that is over the time. At what time the transaction was happened, fraudulent or genuine, and over the amount. This is exploration. Opposite polarity fingerprint over the error in destination account balance, because so I had to balance the both destination account and the origin account. So this is the diagram. This is the visualization. Error based features separate out genuine and fraudulent transactions. Genuine and fraudulent transaction at what time, that is error balance at the destination side, error balance at the origin side. This is a visualization. This is a genuine transaction and fraudulent transaction. This is my data. I split the data into training and testing here. Train using the function called a train test function. This function is available in the sklearn. Test size I have taken 20% is for testing, 80% for training. This is a randomized one. So I use the decision tree classifier. I created the instance, that is CLF instance, just for storing the uh, instance of the decision tree classifier. I use that. I save the model. So once I build the model here, this is once I fit the model, I save the model. Once I save the model has been saved in this drive. So because that model I need to deploy on the Flask web framework. See here I did it. My project 3, in this I have the static folder and the template folders. In the template folder I have index.html because it has a HTML files. In this I have CSS files because that my saved model is here, because I changed the directory. If you want to save in that directory, we need to change the directory predicted. So this is my model accuracy, and I need to explore generate the tree using the these libraries. The libraries export graph which, so this will help us to generate the graph. We can see how I explain in the example in my lecture. So same thing you can see it in this example also, because the tree is constructed based on the algorithm only. This is my tree here. A tree got generated. I saved it here. This is a tree. This is a tree is generated. This is my tree. So this is saved. This is a class 1. Based on the information gain and the entropy only, the tree is constructed. This is all about building the model. Once I build the model, so I need to deploy it. For that, what we have to do, we need to follow the steps to create a Flask here. So we need to follow the steps to create a Flask framework. For Flask is a lightweight web server gateway interface for web application. Flask is a micro web framework written in Python. It is completely written in Python only. Flask can also be used to show the saved model of machine learning, because it is giving the service to the machine learning model to see the results in the front end. So the Flask is giving that. So to save the model, we have to use pickle module to save the module in the drive or disk. Once we save the model, then only we can deploy on the Flask web framework. This is Python pickle module serializes and deserializes Python object structure. This is my direct my project structure directory here. My project name is my project 3. So here I created two folders, static folder and the templates folder. Static folder is which is used to place the CSS files for applying the CSS to HTML. Template folder, this is for keeping the HTML files. This is a model. This is my project. I created it. This is Flask is providing the service. Once user is providing any input here, the user provides input for the required fields on the home page, that is on index.html, that we need to create it. Once we click on the button called predict button, it gives the results using the, because it is routing on the browser with that HTML file. This is what render template, it is rendering on the browser. So the application basically it consists of two routes, home route and the predict. Predict is predicting the results which displays on the front end. Home route presents the home page to the user where there is an input form. This is home and predict. So like this we need to create it. I created it here. If you are clicking on this, you can directly navigate to the Google Colab directly. So you can create it. I did it already, which I shown you. In the first step, we need to go to the Colab. So we need to check whether because we are running our Flask on the Colab, because it is not running on the local machine, it is running on the ngrok, which is Linux, because it is running on the Linux. So we have to check whether it got installed or not. We need to check it. If it is, if the Flask ngrok is not yet installed in a Colab, we need to install it. So this is a way to create a basic Flask app here. From Flask module, import a function called a Flask. This is a library. The library here. This is a library. Flask underscore ngrok, run with ngrok, because it runs on the Linux. This is ngrok. So we are creating the instance. That's the instance is app. So run with ngrok. So routing, this is a home, this is a function. So once you are running the app, automatically it runs on the browser, it runs on the Colab. It is runs on the public IP, because it is not running on the local machine. See, this is local machine. This is running on the ngrok here, this IP. So to run this, we need to check. We must ensure sign up for ngrok account for installing the authorization token. If the authorization token is installed, then only we can run this. Otherwise, you cannot, because it gives the you will get the we'll get this window if the authorization token is not at all installed, because if it is not setting to any account, so it gives this that we need to install it. So we have account, we have to install authorization token. To install that, we need to go to this URL. So ngrok.com download, we have to download, because it is running on the Linux. So this you have to install it. This is a URL. That URL you need to copy and paste it in the Colab, that we have to install in our Colab notebook. Then once it is done, so we need to install this ngrok authorization token in our Colab, because it is authenticated to your account, it is connected to. So once it is done, so the app gets running automatically, runs on this ngrok. This is the way to run the app. This is my project which I created, which I deployed. So this is index.html file, CSS. So this is the way we will get it. So here tab, we need to give this value. Once we click on this, prediction results will be displayed on this. So this is the way I implemented this project. So this is my CSS file. This is not there. Sorry. Yeah. Coming to the conclusion, fraud detection is a serious real-time problem, especially crucial to analyze in the financial industry. A complex domain, and traditional approaches have low accuracy rates and false alarms. The most prominent challenge in modeling an algorithm to solve a fraud detection problem is the classification, whose majority predictions come as fraudulent transactions. Predictive analytics has come up as a better solution for prediction, analyze with the better statistics and model interpretation. With better data modeling and statistics, thorough analysis of data will result in better predictions. Traditional approach towards fraud detection, understanding machine learning for fraud detection. This is conclusion. In the future enhancement, we can further extend by using other models also. These are the references I used to implement this project. I use all these references for implementing this. Can also refer this. Dhanyawad. Any questions are there, you can call me on this number. You can feel free to mail on this mail ID. Thank you. Dhanyawad.